Humans abandoned their nomadic habits and moved into settlements about 40 to 50,000 years ago. We have been using tools even longer, but our ability to send one of the tools into the heavens is much more recent origin, spanning only the past 60 years. Yet, at that time, we have created new tools. We call them robotic spacecraft, and sent them into the cosmos far beyond Earth. Of course, many never got very far. That's the cost of hubris and ambition. But most did, and many never come back to Earth and never will. In that sense, we as a species have already left a mark on the heavens. These small objects that dot the cosmos are a permanent legacy of our species, existing for millions of years, even if we as a planet were to disappear. Spacecraft Luna 3 of the Ye-2 A-class was the first Soviet probe designed to take pictures of the far side of the Moon using the Yenisei unit, using the AFA Ye-1 camera, which consisted of two lenses of 200mm wide angle and 500mm high resolution focal lengths, and a capacity to read up to 40 images on a 35mm film roll. The dual lenses exposed adjacent frames simultaneously. It was also the first spacecraft to be fully powered by solar panels. Strictly speaking, the probe was not meant to reach Earth's escape velocity. Instead, the launch vehicle inserted the spacecraft, called the Automatic Interplanetary Station, Автоматическая метеорологическая станция, AMS, in the Soviet press, into a high elliptical orbit around Earth at 48,200 per 468,300 kilometers, sufficient to reach lunar distance. During the course to the Moon, the EMS suffered overheating problems and poor communications, but the vehicle eventually passed over the Moon's southern polar cap at a range of 7,900 kilometers at 14:16 UT on 6 October, before climbing up northward of the Earth-Moon plane at a distance of 65,200 kilometers from the Moon at 3:30 UT on 7 October, having been properly rendered by its Kaika altitude control system, the first successful 3-axis stabilization used in a spacecraft. The twin-lens 35mm camera began taking the first of 29 pictures of the far side of the Moon. This session lasted a total of about 40 minutes, by the end of which the spacecraft was 68,400 kilometers from the lunar surface. The exposed film was then developed, fixed, and dried automatically, following which a special light beam up to 1,000 lines per image scanned the film from transition to Earth. Images were received the next day after a few aborted attempts at 2 locations: a primary at Semiramis in Crimea known as IP41Y, and backup in the Soviet Far East at Yelisevo in Kamatka, known as NIP6. On the ground, there were 2 systems for recording images from AMS: Yenisei 1 fast mode at 50 lines per second, and Yenisei 2 at slow mode at 0.8 lines per second. 17 of the images were of usable quality, and for the first time they showed parts of the Moon never before seen by human eyes. The day Nicholas left, I took photographs of the objects left behind. The folds in the bed sheets, 2 mandarins on the table, the knives that we used that morning for making breakfast. An attempt to fix his residues. Every taken image was unusable. The photographic film was not able to capture his light.